1 minus x on top. And then the bottom, 2x squared minus 5x minus 3. And with that function, the issue here in part A is to find, oops, I'm sorry, 20 what? Oh, 18, sorry. So never mind. X squared minus 1 is what it is on top then, and then 2x plus 4. Alright, so they ask us to identify asymptotes. So we know that we could have an asymptote or a hole with the bottom equals 0. So if we were to set that equal to 0, okay, ultimately we'd get x equals -2 on the bottom. We also know that it would be an asymptote because if we factored the top, it would be x plus 1 and x minus 1, which would not be anything that would cancel out x plus 2. Right? So therefore, we do have an asymptote at x equals -2. If we were to look at the graph of this, we would see that as well. Or a table would just show us an error, wouldn't necessarily be able to tell. We could by the numbers around it if we look close. But so with that, we have our asymptote drawn and identified. And again, when it says find the vertical asymptote, make sure that that our answer is x equals -2. Okay? If you just say the answer is -2, that's not an asymptote, that's a number, right? An asymptote is a line, which lines have equations. So can't stress how important it is to make sure that we communicate correctly in mathematical terms. Okay? So if you haven't been doing that in the past, now's the time to start. So from there, part of the part B is to describe the behavior around the asymptote. In this case, there's only one of them. So we ultimately just need 2 limit statements for that, as we discussed on Friday. And so we can hopefully answer our question by investigating what's going on with this function near -2 as we approach from the left and from the right, and knowing that our answer is either going to be infinity or -infinity. Okay? And so we could do it really any way that we so choose. We're allowed to use a calculator on this problem, so we could use a calculator and draw the graph, and we could see what the behavior is, okay? And then pick off whether it is going up or down as we approach from the directions stated. So let's see what we got. We got x squared minus 1, 2x plus 4. It looks like from the left, it's coming up and then going right straight down with the asymptote. So from the left should have -infinity for a result, and from the right going down here and then straight up. So this one should be infinity. And again, here's your answer to part A. Answer to part B is both of these statements together. So, like I said, to get this right, key is making sure we understand the directions. So the directions are number 1, give the asymptote. Number 2, describe the behavior. Like I said on Friday, we're not going to write a paragraph or anything. We're going to write 2 limit statements. That's how we describe the behavior. Alright, questions so far? Anything else up through 21? Okay, how about the next part? Up through 42? Actually, you might as well throw 48 in there too. So anything up through the rest of the book assignment? Alright. On 42, we have function x squared plus sine x. And our job here is to find a simple basic function that's a right end behavior model and a left end behavior model. So remember what we discussed on Friday was to take a look at a picture possibly and see if we can hopefully come up with something that might be simpler than the given function. And just double check, I think I have this one in the right mode. It's in radians, so that's good. And when I graph it, it looks kind of like a parabola. And we know that based on the equation here that we were given that x squared is part of the equation. And so like we talked about the other day, a good bet might be one of the parts of the function possibly, might behave like those. And I want you to think about why this would be. And remember we're talking about end behavior, we're talking about behavior at infinity. Okay, what does sine behave like at infinity? keeps going between 1 and -1. So if I put 3 trillion and I squared it, and I added 1 to it, how much different is that going to be than 3 trillion itself? It's essentially the same, isn't it? Okay. So shouldn't we expect as we go to infinity that x squared is the right answer here? Okay. What about negative infinity? Again, if I put -3 trillion in here, I'm going to get something very huge, and if I add or subtract 1 to it, what's that going to do to it when it's that big? Essentially nothing. Okay. So my conjecture here would probably be based on the equation that it's probably x squared on both directions, and it could be the left and right hand behavior. And if you want to, you can graph x squared and see what you think about the picture as it relates to yours. And you know, around the origin it's a little different, we can see, but as we go out to infinity and negative infinity, it looks like the same function, doesn't it? Okay. So our expectation here is that x squared is the right answer on both sides, and that's what we want to try to do with calculators, investigate what simpler function than this is going to behave the same as this function at infinity and negative infinity. So we think the answer at this point for both a and b is x squared. So how do we prove that that's the case? Well, we use limits. So we first start out with our right-hand behavior model. We take the limit as x approaches infinity of our given function divided by what we think the answer is. And remember, what we want to have the answer to this be is 1. Because if the answer to this is 1, that means these two functions are essentially the same. Okay? And if they are the same function, then they behave the same at infinity. Okay? So remember, the algebra of this is to separate separate those two. This one here is 1, of course, and then the limit as x approaches infinity. As we approach infinity, sign again does not grow. This grows very quickly, okay. And so ultimately the bottom numbers are bigger. So therefore we have small on top, big on the bottom. Ultimately that ends up being what? 0. So that analysis, that work, is the proof. Okay. So if I didn't have these intermediate steps right here, would that be enough to show that it's true? No. Make sure we show these intermediate steps, that part is the proof. So that means that, and again, what are we trying to show? We're trying to show that x squared is the right-hand behavior model. We've done that. Okay, so now we can conclude that that is a fact, that x squared is the right-hand behavior model. So to do it the other way, go on the left, we go negative infinity. Same exact procedure. We get 1 plus, and again, considering negative infinity here, sign going left still does the same thing. X squared gets big, and so therefore that's also 0, and our answer then is 1. So we can show that that ratio, the limit of that ratio as x approaches infinity is 1, which means that these two behave the same at negative infinity, and therefore x squared, a simpler function, is going to be the right-hand behavior model for this function. Okay? So those two behave the same at infinity and negative infinity. Okay? So for parts A and B, both answers would be x squared, and here's our proof. Questions on any part of that one? Alright, what else? Anything else in the book assignment? Alright, how about the packet assignment? So if you had page 68, nope, I lied, page 77, 59 through 64, and then also the quick quiz. I believe on most of these copies I gave you the answers on there. Some may or may not be easy to read though, depending on how good the copy is. So I'll read them to you regardless. So 59 through 64 are going to be as follows. 59 is somewhere on this page. Maybe. Oh, we'll just figure it out then. Oh, there it is. It's true. So it says it is possible for a function to have more than one horizontal asymptote. Okay, that is true. Remember we talked about if the right-hand behavior, if you will, say goes to 1 and the left-hand behavior goes to 0, we'd have two different horizontal asymptotes depending on which direction we're going. Okay, so so that could happen. Number 60 is false. And then that one, again, we have if f has a vertical asymptote at x equals c, so somewhere, then either the limit as x approaches c from the left equals the limit as x approaches c from the right, which both equal infinity, or they equal each other and they both equal negative infinity. So again, that saying if we have a vertical asymptote, do they both have to go up or both go down? Do they have to be the same as we approach from left and right in terms of infinity or negative infinity? I mean, we know functions that do have that, like 1 over x squared. 1 over x squared goes up in both directions, right? If I had negative 1 over x squared, it would go down in both directions. But don't we have 1 over x, which is one of each? One goes up, one goes down, depending on whether we're coming from left or right. In fact, we had a problem that we just did in our homework that was like that. That would be a counterexample to that, so therefore that would be false. And then the multiple choice, 61 should be A, 62 is E, 63 is C, 64 is D. And the quick quiz, number 1 should be D, 2 is A, 3 is E, and 4 in the free response, the domain should be negative infinity to 0. And I'm going to write that down because I want to make sure we're clear on how we should indicate domains. We learned hopefully in pre-calc to use interval notation. So if we had something like x on the bottom of whatever, and we wanted to, we know that x can't equal 0, then our domain then would be negative infinity to 0, union 0 to infinity. So make sure when we're listing domains and ranges that we're using interval notation. Okay? Don't just write x equals 0, x cannot equal 0. So everything should be in interval notation in this class. So again, all this just covers the whole line from negative infinity to infinity. And since we have parentheses around the 0, that means 0 is not included. What if we did want to include something? Put brackets. Should we ever have brackets around infinities? No. Never actually get to infinity, so it should never have brackets around infinity. Okay. So that would be the domain, if you will. The range is every y value is hit, so it'll just be negative infinity to infinity for the range part of that one. The limit as x approaches infinity should be 0. And part D we can skip because we did not do anything with the sandwich theorem for this class. Alright, how about anything from the packet problems? Any of those we want to discuss or talk about? Yes. So we got limit as x approaches 3. So this is on our quick quiz. So we got limit as x approaches 3 of x squared minus x minus 6 over x minus 3. And again, our job here is just to find the limit if it exists. So first step is direct evaluation. We can't do that because if we put a 3 in here, we're going to get 0 on the bottom. So then from there, step 2 is can we do any algebra to simplify this expression? Well, on the top, if we have x squared minus x minus 6, if we factor that, we could go minus 3 and plus 2. Do the correct factorization of that top. And with that, we can cancel those out and be left with a new expression, which is just simply x plus 2. And now we can directly evaluate, put our 3 in there and get 3 plus 2, which is 5. Alright, so again, one of the things in calculus at this point is if we have an expression like that, we got to be able to factor that immediately. Right? So if you have factoring issues at this point, you need to do something about it. So you can go on the internet and print off factoring sheets that are a mile long if you want to and practice making sure you can factor, because when doing calculus you don't want to spend 10 minutes trying to figure out how to factor that fairly simple equation across at this point. So as we do some of this algebra stuff, if you're finding that you have a weakness somewhere that needs to get fixed, okay, well, try to fix it. The quicker you can do algebra, okay, and the more accurate you can do algebra, the easier calculus is. Okay. Most people that don't do well in calculus is because they do not do algebra very well. So if you find a weakness, okay, let me know and I'll help you find a way to make it not a weakness anymore. Okay. All right. Anything else from the packet?